Okay, this is lesson 8.5. We're talking about special types of linear systems. And your objective is to identify linear systems as having one solution, no solution, or infinitely many solutions. Okay, let's go ahead and get started. Okay, one way to tell what kind of solutions linear systems have is by looking at graphs, okay? So if the lines intersect, remember, then the solution to the system is where the lines cross each other at the point. So when lines intersect, because they cross at one point, then they have one solution. Okay, if lines are parallel, then they never intersect. So that means they have no solution. And if lines coincide, then they have infinitely many solutions. Okay, so that means that the coordinates of every point on the line will be a solution to the system. Okay, now we can also tell algebraically using substitution, elimination, or something else. Okay, now a system that has one solution, you might get an answer like x equals 7 or y equals 2. Okay, and then your solution will be the ordered pair. Okay, that means the solution or the system has one solution. A system with no solution, you might get something like this, where we get 2 equals 7, which is never true. Okay, so that means there's no solution, since 2 never equals 7. Okay, and algebraically, an answer where lines coincide or there's infinitely many solutions, okay, that might be when you get an answer like 1 equals 1, or x equals x, or something like that. Okay, because those things are always true. 1 always equals 1 and x always equals x. Alright, so those are examples of what your algebraic answers would look like. So again, if you get one that looks like this, then you would write that as an ordered pair. If you get one that looks like this, that means there's no solution. So that would be your answer, no solution. And one that looks like one of these would be infinite solutions. Okay, because this is always true. So let's look at a couple examples. Okay, tell how many solutions the system has. So we can use any method that we want for these. Okay, I'm going to solve this one by substitution. Reason is because I've got a single coefficient here, and it should be pretty easy to use substitution on this. Okay, so I'm going to start by saying that y is equal to 4 minus 2x. Okay, using substitution. So then I'm going to plug that in again to this equation. So I'm going to have 4x, and instead of minus 2y, it's going to be plus negative 2 times my y, which is 4 minus 2x, or 4 plus negative 2x. And that's got to equal 0. Okay, so we're going to distribute and get 4x plus negative 8 plus 4x equals 0. Well, I can combine my x's and get 8x plus negative 8 equals 0. And if I add 8 to both sides, I'm going to get 8x equals 8. And I'm going to get x equals 1. Okay, so now I should be able to tell if x equals 1, then that means that I'm going to have one solution to this. So I'm going to write that as an ordered pair. I'm going to have 1 and something else as my answer. And to figure that out, I'll plug it back into the top equation here. So I'm going to have, instead of 2 times x, it's 2 times 1. Or actually, sorry, let's plug it into the substitution equation that we had over here. Okay, so I'm going to have y equals 4 plus negative 2 times my x, which is 1. Okay, and that's going to be y equals 4 plus negative 2 times 1 is negative 2, so that's y equals positive 2. So my solution is 1, 2, and it says to tell how many the solutions has, so I'm going to put one solution. Okay, if it says tell how many solutions it has, if it actually has a solution like this, I want you to write it down. Okay, so the solution is 1, 2. And if I plug that into this equation, 2 times 1 plus 2 is 4. Or plug it in here, 4 times 1 minus 2 times 2 equals 0, so they both work out. Okay, so this one is an example of one solution, because I got one answer, one ordered pair. And let's go on to the next example. Okay, and here we have another one. Okay, we'll solve this one by elimination, just because. So, I'm going to put, let's just multiply that top equation by -1 so that will make the y's opposite coefficients. Okay, so the very first thing I'm going to do is rewrite both equations, because Mr. Ayers likes to do that in his own handwriting because it's so beautiful. Okay, so I'm going to multiply the top equation by -1. So I'm going to have -2x minus y equals -5. Well, 2x minus 2x cancels, y and -y cancel, so that leaves me with 0 over here. And 1 minus 5 is -4. So I get 0 equals -4. That is never true, impossible. So the answer is no solution to this one. Because again, 0 never equals -4. So there's no solution to that system. So again, we get an answer like this where it's never true. Our answer, no solution. And again, we could have probably seen that from the start. Okay, we might have been able to figure that out logically in our heads, but show me the work, show me the proof for that. Alright, and we have one last example. Alright, and this last one here again. First thing Mr. Ayers is going to do is rewrite the equation in his own handwriting. And I don't care what method you use to solve these. You pick the one you like the best. Substitution's good, elimination's good, it doesn't matter. Graphing, probably not the quickest way to do these, but you could do that as well and grapple with the lines. Okay, I'm going to solve this one by elimination. I'm going to go ahead and multiply this top equation by 3, so that way I'll have opposite y coefficients. Okay, so now if I solve this, 3 times 3x is 9x plus 3 times y, and 3 times -1 equals -3. So now I'm going to combine these. Again, -9 and +9 cancel. -3 and +3 cancel. That leaves me with 0 over here. And 3 and -3 cancel and leave me with 0. So I get 0 equals 0. That means that that is always true. Okay, and since that is always true, 0 always equals 0, then the answer is infinite solutions. Okay? Infinitely many solutions. Infinitely many solutions, because again, 0 always equals 0. Okay, always true. And that's your lesson, pretty quick one. So good luck on your homework.